We'll discuss method of induction and also sigma notation in this particular video. It forms a foundation. How do we prove using the method of induction? Thank you. Enjoy the journey of learning with Anil Kumar. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we have taken question from IB test paper. It is based on proving using mathematical induction method. We need to prove that sum of 2 to the power of r, where r is from 1 to n, is equal to 2 to the power of n plus 1 minus 2 for all integer values, positive integer values, where n is greater than equal to 1. You can always pause the video, answer the question, and then look into my suggestions. In case you want to learn directly from me, feel free to send an email on globalmathinstitute@gmail.com. Let me also thank all the viewers and subscribers for watching my videos, posting excellent comments, and contributing in the form of beautiful questions and also donations. Because of your questions, we provide you with best solutions, absolutely free. Since 15 years, we have been providing you free services. We have now more than 17,000 videos which are being watched in more than 80 countries. Keep contributing so that we can reach millions. Thanks for your contribution and all the support. This is your own channel. Now, let's continue with understanding the question and then we are going to solve it. Now, some of my students might not be very familiar with the sigma notation. Well, sigma notation is the short form of writing, right? So we have r equals to 1 to n, and we want to add all the terms which are 2 to the power of r. If I take r as 1, then it becomes 2 to the power of 1 plus 2 to the power of 2 plus 2 to the power of 3 plus so on till 2 to the power of n. So that is what it really means, right? So I hope the sigma notation is absolutely clear. Now, second thing which we want to understand is the method of induction. So method of induction includes 3 steps, right? Method of induction. Step 1 is prove it is true for n equals to 1, right? Prove it is true. So sometimes we are solving equations, sometimes inequality. So whatever it is, we need to prove that it is true for n equals to 1. This is our first step. And if that is the case, then we move to the second step, and the second step is assume it holds for n equals to k. And step number 3 is to show that it works for n equals to k plus 1, right? So that means the next term, and so on, right? You see? And if that is true, if you show all the 3 steps, then we say we have shown this identity or inequality has been proved using method of induction. Many difficult questions are easily solved or proved using method of induction. So we could generate new formulas using this method. That is the power of this method. So understanding this strategy is absolutely clear. So I hope you have understood everything here. What is the sigma notation and what is method of induction? And now we can begin by step number 1. So let's go to a fresh page. So once again, we have Now, to show that this sigma r equals to 1 to n, which is sum of all the terms, right, is true for n equals to 1. So if in this case n is equal to 1, that is first term, you get the idea, because n greater than equal to 1, so r will be 1, right? So n equals to 1 means in this case r equals to 1. So then we have only one term, which is 2 to the power of 1. So 2 to the power of 1 is equal to 2, and also this is our right hand side, correct? Left hand side, correct? And on the right hand side, we have got 2 to the power of 1 plus 1 minus 2, which is 2 to the power of 2 minus 2, which is 4 minus 2, which is also 2, and that is the right hand side. So we have shown that left hand side is equal to the right hand side, right? So that shows, right? Correct? So now, step number 1 is done for us, correct? We have shown that left hand side equals to right hand side for n equals to 1. Is that clear to you? Now let's move on to the second step, which basically is let n equals to k be true. That is to say, we are saying that sum of all these terms where r is equal to 1 to k, right? So we have 2 to the power of r is equal to 2 to the power of k plus 1 minus 2. Make sense? So that is what it means, right? So sum of first k terms in this particular series, which is 2 to the power of r, is true. So we will assume this to be true. And now we have to do step number 3, which indeed is to prove this sum, when extended to k plus 1, it will become 2 to the power of r, right? Which should be equal to 2 to the power of k plus 1 minus 2. That means k plus 2. Clear? So this is what we need to prove, correct? So let's go to a new page and try to prove it, right? So now let us prove it on a fresh page. So we already know that we have assumed that sum of first k terms of this series, which is from r equals to 1 to k, 2 to the power of r, is indeed equal to 2 to the power of k plus 1 minus 2, right? So that is correct. Now we need to show what? We need to show that the sum of k plus 1 term for this particular series, 2 to the power r, should be equal to 2 to the power of k plus 1, right, minus 2, which is 2 to the power of k plus 2 minus 2. Is that clear to you? So this is what we have to show, right? Now let us see what is this sum 2 to the power of sigma notation r equals to 1 to k plus 1, right, is equal to sum of first k terms 1 to k, right, 2 to the power of r, plus the k plus first term, right, which is 2 to the power of k plus 4. Is that okay? Now first k terms we already know is equal to 2 to the power of k plus 1 minus 2, right? And then we have 2 to the power of k plus 1. Correct? So that is how we get our equation. And now from here, we can take 2 to the power of k plus 1 as common, right? And we can add these two, right? So adding these two becomes, we are adding these two terms, right? Which is 2 times. So it is 2 times 2 to the power of k plus 1, correct? Minus 2. So 2 is common here. So we can rewrite this as 2 is common, right? And we can rewrite this as 2 to the power of k plus 1, and this times 2 can be add this, right? Is it okay? Minus 2, which is indeed equals to 2 to the power of k plus 2, right? Minus 2. Do you see that? So we have shown that the left hand side is equal to the right hand side which we wanted, right? Which is the right hand side. Hence proved. Makes sense, right? So basically, we started with the assumption that this identity is true for n equals to k, and we prove that it is also true for n equals to k plus 1, right? Hence, this identity holds good for all the values of n greater than or equal to 1. Is that clear to you? So I hope with this, you have understood the strategy. How do we work with method of induction in such cases? In case you want to learn directly from me, feel free to send an email on globalmathinstitute@gmail.com. Your support is very critical at this stage, so keep supporting. It's your own channel. Thanks a lot and all the best.